Okay, so to solve this particular absolute value inequality, we want to first isolate the absolute value. Okay, so here's my absolute value portion. We want to isolate the absolute value. So how do we do that? Move everything away from it. Okay, so first thing I'm going to do is we kind of work in reverse of normal PEMDAS or order of operations. We're going to do the kind of the furthest away things first. We want to get rid of that plus 2 first. So I'm going to subtract 2 from both sides. Okay, so this yields, of course, 4 absolute value x minus 5 is less than, let's see, 11 minus 2 is 9, right? Next thing I'm going to want to do is let's get rid of this 4. It's multiplying. To get rid of a multiplication, we do division. Remember that if you multiply or divide by a negative, the direction of the inequality switches direction, okay? Flips around. If you multiply or divide by a negative. In this case, we're dividing by a positive, so we're okay. So we end up with absolute value, x minus 5 is less than 9/4, okay? Now, remember, an absolute value technically means the distance that the quantity is from 0. So essentially what we're saying is this x minus 5 quantity, we don't know what it is, but its distance from 0 on the number line is less than 9/4. This is really the distance of x minus 5 from 0. Distance of whatever's inside the absolute value, in this case the x minus 5, from 0 on the number line. Okay, so if that's supposed to say 0. So if I draw a number line, so here's a number line. Okay, so here is negative infinity way out here, infinity's way out here. Here's 0. The distance of this unknown x minus 5 from 0 is less than 9/4. So how can you be less than 9/4 away from 0? Well, what if you're in here? Anything between 0 and 9/4, the distance of anything in this yellow region would be, the distance from 0 would be less than 9/4, correct? What about on the flip side? What if I go from 0, what if I go down to negative 9/4? What about this stuff here? Let's call this the, I don't know, the green region. What about this green stuff here? Anything in there will also be less than 9/4 of a unit away from 0. Okay, so what we're seeing is we're essentially, when we have an absolute value with a less than scenario, when we isolate the absolute value and we end up with a less than, that means that the quantity inside the absolute value, this is where the x minus 5 can live. The x minus 5 quantity, whatever's inside the absolute value, can either be here or there. Okay, so that means we are between the positive of the right-hand side and the negative of that same right-hand side. We can only say this once we have the absolute value isolated. Okay, so what I can do is I can say x minus 5 without the absolute value has to be less than 9/4, but it has to be greater than negative 9/4. Now, if there was an equals symbol underneath a so-called relative inequality, meaning you're allowed to equal the number at the end, then all of these would have an equal sign, and we would have equal signs here. Okay, everything works the same. So the final step now is, now that we know where x minus 5 lives between these two numbers, I want to now figure out where x lives. And to figure out where x lives, I just have to get rid of the minus 5. Okay, so how do I get rid of the minus 5? I'm going to add the minus 5 to both sides. Well, I'm going to add 5 to both sides. I'm going to say plus 5. And really we have 3 sides to this inequality. We have the middle and then we have the two ends. So I'm going to add 5 to all of these quantities. But notice that this is really a fraction. So I'm going to think of this as a 5 over a 1. And then, of course, I can make a common denominator by multiplying by 4 and 4 top and bottom. It just changes the appearance, not the value. So this is 20. I'm adding 20/4 in both cases. Okay, 20/4 is being added. So instead of doing 5 over 1, I'm just going to add 20/4. So 9/4 plus 20/4 gives me how much? Gives me 29/4, right? So this side's going to be 29/4. Whoops, I'm running out of room here. Okay, and then negative 9/4 plus 20/4 gives me 11/4. And then in the center, notice that in the center, these 5's canceled, so I just have x. Okay, so x has to be between 11/4 and 29/4. Okay, so if I draw that on the number line, I'll draw a new number line. This was a number line. This first number line was a number line to see where the inside of the root lives, the x minus 5. Okay, once I figure out where x minus 5 lives, I can then find out where x has to live. And we found x has to live between 29 quarters and 11 quarters. Has to be in here. Okay, so to write that in interval notation, we would say x has to be, well, we actually have it here. X has to be less than 29 quarters, greater than 11 quarters, or we can write that as an interval, 11 quarters through 29 quarters. Okay, where it's a rounded endpoint because we're not including the two endpoints themselves. Why are we not including the two endpoints? Because there was no equal sign in the original problem. Now notice in the book they talk about an and. I find that to be, yeah, I mean it's valid, but it's a pain in the neck. In the book, what they do at this stage is they will say, well, the x minus 5 has to be less than 9 quarters, this part, and at the same time, the x minus 5 has to be greater than negative 9 quarters. And so both have to be true at the same time. And then you have to solve both inequalities and put things together, put the results together. I find that to be a lot of trouble, okay? If you have isolate the absolute value, you get to a stage where your absolute value is isolated and you have a less than scenario, absolute value less than a quantity. That means you simply, the stuff inside the absolute value, the quantity inside the absolute value has to be less than the number that you have, but at the same time greater than the negative of that number, and that means it has to be between those two quantities. So we have what's called a three-sided or continued inequality. This is called a continued or three-sided inequality. And I find it much easier to work with. And we use them when we have a less than, an absolute value less than a number. And you only know if you have that if you, isolate the absolute value. You don't really know that ahead of time because things could change as you're isolating the absolute value. Okay? Now, what about if this was a greater than problem? Okay, so let me go ahead and clear this. And let's try the same problem but with a greater than. Okay, so I'm just going to create the problem again, but now we have new version where we're going to change things a little bit. What if I had 4 absolute x minus 5 plus 2 is greater than 11? How would that change things? So the first step still is isolate the absolute value. We want to isolate this guy. How do we isolate that guy? Well, we're going to move the 2 away, right? So subtract 2 from both sides. So we end up with 4 absolute x minus 5 is greater than 9. Then we're going to divide both sides by the 4 because we're trying to isolate the absolute value. Okay, and so we end up with absolute value of x minus 5 is greater than 9 quarters. Now, is this a less than? Or is this a absolute value less than? No, it's an absolute value greater than. Okay, how do we deal with those? Well, remember, absolute value means the distance of the quantity from 0 on the number line. So this is the distance of that quantity x minus 5 from 0 on the number line. Okay, so I'm going to draw myself a quick number line. Here it is. Negative infinity, infinity. Here's 0. I have to be greater than 9 quarters units away. So here's 9 quarters. Let's also mark down the negative of the other side. Negative of 9 quarters because we're going to need that also. Sorry, that's a negative 9 quarters. And you have to be more than 9 quarters away from 0. How could you be more than 9 quarters units away from 0? Because greater than means more than. More than 9 quarters of a unit away from 0. That means you have to be past 9 quarters. You have to be out here, or you can be over here. So this yields an or scenario, one or the other. You don't have to be, if this was a less than, then you'd have to be less than 9 quarters and greater than negative 9 quarters at the same time. That's an and. And is a bit of a problem to work with. That's why we just do a between statement. If you look at what we did before, we just say that we're between negative 9 quarters and 9 quarters. So a less than problem can be done with a between. But a greater than means you have to be past the positive of the number, greater than the positive of the number, or less than, meaning to the left of the negative of this number. Okay, once you've isolated your absolute value. Okay, so each of these is a simple, each of these is its own little problem. So over here, we just have that the x minus 5 without, remember, this is where the x minus 5 lives. The inside of the absolute value. So I know the x minus 5 has to be greater than 9/4. So if I add 5 to both sides, again, I'm going to think this is a 5 over 1, get a common denominator, multiply by 4s to get a common denominator. So I'm going to have x is greater than 9/4 plus 20/4, 29/4. Okay, now how about over here? How about over in this area? I'm going to have, again, I have the inside of the absolute value to the left of, meaning less than, negative 9/4. So when we have a greater than scenario, absolute value greater than, you have to be, the quantity inside the absolute value has to be more than the positive of the right-hand side or less than the negative of the right-hand side, because you have to be more than 9/4 units away from 0. Okay? And then just isolate the x to see what this says about x. Right now, we know what's going on with x minus 5. The inside of the absolute value is x minus 5. I want to know what's happening to x. Okay, so I'm going to add 5 to both sides, but of course on the right, I'm going to think of it as, get a common denominator. I'm adding that to both sides. So this is just x less than, and here I have 20/4. Take away 9/4 is what? 11/4. Okay, and then is this an or an and? Well, it's an or. You can live here, or you can live here. Okay, x minus 5 can live in either of the two places. It doesn't have to live in both at the same time. So it's an or. Okay, greater than is always an or. Less than inequalities, absolute value inequalities, or an and, or a between statement is even better. Okay, like we did before. So how do I write this in interval notation? Well, basically I'm going to redraw. This is a number line for the x minus 5. I'm going to draw myself a number line for where x has to live now. This is my number line for x. X has to live greater than 29/4 or less than 11/4. So greater than 29/4 is out here. So x has to be greater than 29/4 is out here. X has to be less than 11/4. So this interval right here, just mark down the endpoints, negative infinity to 11/4. You can just see the endpoints. This is a shaded region. Think of this as being shaded in. This is the stuff we want. This is also the stuff we want. Okay, either of these is okay. So here I have negative infinity to 11/4. That's the shaded region. Why am I using round brackets? Because there's no equal sign. Okay, and then here, 29/4 to infinity. Just write down the endpoints of the shaded region. 29/4 to infinity. Okay, and then for either we use a union. Union is what we use for, I wrote union. Union is what we use for or scenarios. Okay, or scenarios, and or scenarios come from absolute value greater than. How come? Because that means you have to be further away from 0 than this number, meaning you can be past the positive or to the left of the negative of this number. Either case would put you more than 9/4 of a unit from 0. Okay, so it's an or, one or the other. You don't have to have both at the same time. If this was a less than, like we did before, then we would say that my x minus 5 has to be between these two values. Okay, and that's how you do these. Cool, huh?